So what we're doing right now is, I told you, we'll focus on coordinate transformations for this assignment. If you look at the assignment itself, so the first one is pretty simple. First one is, we have done it in class. What happened, Quincy?
Somebody seemed to have taken the updated sharpener.
You want a sharpener? $100.
As long as you pay for it.
Huh?
As long as you pay for it.
If you reimburse it, I'll pay for it. So the first one is pretty simple, okay? It's you're given R and V, and you have to prove that F. Make sure you understand this, okay? Why, and I may ask you explanation why something. If you take steps in proving this, you have to know. You have to justify why. Okay? The second one. Do you understand the second one?
No. You got do the 313, so you get like if you look at it, it's like R1 has a certain vector associated with it, and you have to apply those to
So the second one. So we are talking about transforming ECI to PQW. Again, we have discussed this in detail in our lectures. So what is the ECI frame? ECI frame, how do you identify the ECI frame? To be aware by now. Huh?
either or isn't that the editorial?
Is it? It is?
Isn't that the editorial?
No, frame, ECI frame.
That's the second. That's the very first one.
You cannot keep forgetting, okay? ECI frame is, you have x-axis, which is the vernal equinox. You have the z-axis, which is the axis of Earth's rotation. And then y-axis is simply y is equal to c cos x. Okay, and what is the PQW frame? And what is the p-axis? The perigee direction. Okay.
That's the axis of what the object's rotating on.
Not Q, actually the W axis. Direction of and Q axis just completes. See, if you've done your assignment, if you've done your previous assignment and you don't know this, then it doesn't help. When you've not done your assignment, you've not really understood what you've done. Okay? So go back and review what you've done. You have to remember what ECI frame is. I mean, we have discussed this many times. From the beginning of the course, we have been discussing what ECI frame is. Okay? If you keep forgetting, then see, it doesn't make sense for me to, for example, it doesn't make a whole lot of sense for us to discuss this assignment if you don't understand this basically. This assignment builds on assignment number, the previous assignment. Okay. Did you do coordinate transformation in the previous assignment? You did a 3-1-3 rotation in your previous assignment?
Yeah.
You should understand that. What is the 3-1-3? What is ECI frame? So we'll just, I don't think we should discuss this assignment. I think you guys are not, what you do is, if you're ready, next class we'll discuss it. Okay? Otherwise, I'll leave it up to you.
I'll be starting with you.
Hmm?
I'm going to discuss with you.
Yeah, like that's the one I have.
Just a hair start.
So yeah.
Like the others, like.
So how do you do, tell me how do you do this then? If you're having problem with 3, how do you do 2?
It's a 3-1-3. So we.
If you're having, see, I know it is in the textbook.
This one? No,
The
this
second one is in the textbook. If you just,
No, this one.
huh?
That's not in the textbook.
The exact same process is in the textbook. If you're just going to look at the textbook and say, I understand, or if you're just going to copy and give me that, then it doesn't make sense.
You gotta do the dot product. You
Hmm?
gotta do the dot product with 3-1-3.
Dot product?
I mean, we'll multiply the matrix.
That's not dot product. You cannot do dot product on matrices. How can you do dot product of matrices? Hmm?
No, it's not. It's just like multiple. The matrix together.
It's matrix multiplication. Louis? Your cell phone? So, do you understand the second one? Do you really understand the second one? Or are you just going to give me the solution from the textbook? Hmm?
You gotta go through the whole process.
There's a similar one, but it's not.
See, if you understand, if you think you understand, tell me how you do it. Tell me the process. Or you don't understand?
The whole problem statement gave the process.
Tell me the first. Okay, tell me the first step. What are you going to do?
So I'm gonna set up my different matrix.
Huh?
I'm gonna set up my different matrices. Alright.
What is the problem? What is the problem asking you?
Show that I have to read it. I have to read it, but it wants you to like basically show how you transfer, how you go from PP value to ECI to PP value.
What is ECI?
That's the next one.
I mean, no, it is. It's not close kind.
This is, you cannot just read there and tell me. I know what is there in the textbook. I want your understanding.
I know what you look at.
Huh?
You asked what it is.
I can read. What is ECI? ECI is not DCM. What is ECI? What does ECI stand for even? Do you remember what ECI stands for? Huh? Earth Center Inertia. So what is it? What is it?
Coordinate planes.
I feel like it's the Earth rotation with respect to like the affixed
Like
coordinate
the datum, you like the datum at the center of the Earth.
It's a coordinate. You understand what a coordinate system is? What is a coordinate system?
This is a set of coordinates like kind of help you with direction.
What is a coordinate system?
It gives the position of something.
Hmm?
It allows the position of something in a particular system.
It's a position system.
It is where to locate anything.
Hmm?
It is a way to locate anything.
Based off
In
of
a space or
based off of
any
reference point.
frame.
It's a grid.
To give me an example.
An X, Y, Z plane. We can use
You cannot see. You cannot have a X plane. You cannot have a Y plane. Can you have a X plane?
No, x-axis.
No.
X, Y plane.
Okay.
X, Y plane. Yeah, X, Y, Z axis.
Okay.
And
What does X, Y, Z axis mean? What do they have to be?
the three dimensions that you
Huh?
can use apart.
Each of the axes are the magnitude perpendicular.
Okay.
Z is equal to X cross Y.
Okay.
That's
What else?
the magnitude.
The XY axis and stuff like that, it serves as orientation.
Hmm?
It serves as orientation.
It say
It serves as orientation, so that's why we use it with plants and stuff, because in space there's no real orientation unless we set one.
when you talk about position, when you talk about orientation, how do you define position?
You have to use like
With
a
reference to
reference
anything.
point.
Right. So that with reference to is that reference coordinate system. The reference frame itself cannot define position or orientation. Similarly, how do you define orientation?
Direction.
That will also be with reference to
It will again be with reference to a coordinate system. You understand?
Yeah.
Orientation and position is always with reference to, position is with reference to what? With respect
To the origin.
huh?
Reference to a
With
origin.
reference to a point. Position is from one point to another, right? So when we say with reference to, that reference is the reference coordinate system. Okay?
So ECI is the reference point for anything that
Not point,
Reference frame.
frame.
reference frame or reference coordinates frame.
Okay.
Reference coordinate system or reference frame. So any reference frame will have to have three axes, which are
X, Y, Z.
orthonormal. Orthonormal means they are perpendicular and they are unit vector. Why do they have to be orthonormal?
It's a standard.
90 degrees.
It's a standard of how we would.
Just, okay, don't worry about why they have to be, but they have to be orthonormal. They have to be perpendicular to each other and they have to be unit vectors. All x, y, z axes have to be unit vectors. Now, how do you define orientation? So you have one reference coordinate system, okay, and you have another reference coordinate system. The orientation of this reference coordinate system with respect to this reference coordinate system is orientation.
So it's
So the reference, the orientation, so this is your reference frame or reference coordinate system, ECI. This is another reference frame. This reference frame defines the orientation of the orbit. PQW defines the reference just like what is this? This x-axis, y-axis, this can be used to measure anything in the ECI frame, right? So if you have this reference frame established, you can measure position and relative orientation of this.
so you could say it's the relation of the new reference frame with respect to the old
Yes.
frame.
So when you talk about, when you discuss what is the direction of P with respect to x, y, z? Okay, what is the direction of W with respect to x, y, z? What is the direction of Q with respect to x, y, z? You get the orientation of this with respect to this. See it?
So what's the difference between ECI and ECF? What's the difference between ECI and ECF? I've seen both of those be written out, but they seem like the same thing to me.
It's not the same thing. ECI frame ECF is fixed to Earth. So what happens if you fix something to Earth? It rotates with Earth. ECI is not fixed to Earth.
Oh, okay.
The direction of this XYZ is always the same.
Oh, ECI is what you use to make a relation between the PQW, because if you use ECF, it'll constantly be changing.
It will constantly be changing.
Okay, yeah.
So you cannot really, the orientation will be constantly changing. Okay? So we don't do that. We do ECI. ECI it's constant. The frame is fixed in space. This x-axis will always be vernal equinox. ECF, this x-axis will not be vernal equinox. As time progresses, it keeps on changing since Earth is rotating.
You can call PQW the instrument frame. Is that the same thing, or is that something different?
Instrument frame is different. PQW is the orbit frame.
What's this?
If we have, this is Earth. This is how you are. ECI, this is x-axis. This is y-axis. This is z-axis. Okay. So this is the axis of rotation. Now, if we have an orbit, we have an equatorial orbit. Okay. Now let's look at a polar orbit. So what is a polar orbit? This is a polar orbit. Okay? Polar orbit is something, an orbiting body which crosses poles. Okay? Now, what is the inclination here? Zero. See, that's what you're saying. You're not doing your homework. You're really not doing your homework. It should be very easy what the inclination here is. What is the inclination?
The angle between the two planes.
Yeah. Where is the equatorial plane here?
Is it like the X, isn't it the X, Y? It's
Yeah. So what is the inclination then?
90 degrees.
Huh?
90.
90 degrees. So you should be able to. You cannot. You should not think so much if you're doing your assignment right. Just 90 degrees. It's simple. So what direction is the angular momentum vector here? If this is the direction of motion.
Perpendicular to the inertia. Between Z and X.
Perpendicular to the inertia.
Oh. Between Z and X and whatever. Between Z and X and whatever.
It's going
Angular momentum vector is what? It defines
it's
the motion.
perpendicular to the inertial frame, so it'd be going out.
So
It'll come out.
that's hard.
Hmm?
So the circular orbit is that's the orbit, right? That's right here.
Mm-hmm.
So that's hard. You could draw this chart.
This is actually angular momentum vector. This is y-axis, and it's also the angular momentum vector. You just look at this. It's like this. It's like this, right? It's going like this. So this defines your motion. See that? It defines your motion, your polar motion. You see it? You don't see it?
That's
Hmm?
So it's
Rotating
always
up,
the
rotating.
inertial frame, and that's the inertial frame going around something like this. So if it's going around that way, your inertial frame will be, perpendicular to your inertial frame will be out this way. Which
It's
is-
not perpendicular to the inertial frame, it's perpendicular to this plane, the orbital plane.
Okay.
So it's this way.
And the orbital plane was slicing.
If I
Orbital plane is slicing, yes.
I need to see R and E.
Huh?
I need to see R and E.
R and E.
Yeah.
R is depending on where your this thing is.
Because it's elliptical, right?
Huh?
Because it's an elliptical orbit, right?
Yeah. It's not, it need not be elliptical, it could be circular as well. So when you do this,
I came in, but when we're doing number two, are we supposed to, do each rotational matrix, as we're doing like multiply the first matrix, the rotational matrix with the second one? And then do that when we got that matrix, multiply with the third rotational matrix?
No, I'm sorry.
Is that what we're doing?
Right.
Okay.
So you're saying, he's gonna say cosine, like little omega cosine. Omega.
Yeah, like he did the different rotational matrix, and I guess we're supposed to just do like the 3 multiply that matrix multiply with the rotation 1, and then when you get that matrix multiplied again with the 3 rotations, because I think it was like 3 1 3, so I think that's how we're supposed to do it.
Alright, look at this now, okay? So there are two satellites out here. One is in a polar orbit, the other is in a geostationary orbit. What is the ECI frame here? How do you define where will the ECI frame be?
ECI frame would be equator.
Huh? Frame. See, I'm talking about the frame. You cannot just differentiate between plane and frame. I'm not asking plane. The red one is a plane. You understand plane? Am I clear in my this thing? I'm not asking for plane. When I ask for frame, you have to give me 3 axes. Always. Don't give me plane. So what is the ECI frame?
X, Y, and Z.
Okay, where would XYZ be? Try to tell me where XYZ would be.
For the polar orbit or which orbit? Yeah, there's 2 orbits, so how do you know one?
ECI frame
Oh,
is
ECI.
ECI frame. What is the ECI frame? ECI frame is fixed, only one.
So the the x-axis is coming out of the screen. The x-axis will be coming out of the screen.
Okay.
The z-axis will be going through the satellite,
Okay.
and
The
the y-axis is z cross x.
So y-axis is in this. So you see this plane is the YZ plane. You see it? Raju, you're doing something important. So this plane is YZ plane, okay? And you're right, x-axis is coming out. ECI frame is for Earth. It is always the same. So now tell me, what is a PQW frame?
It's different from the orbit, right?
Yes.
So,
So the PQW frame would be different for both orbits. What is the PQW frame for
Geostation.
the geostationary?
so the Z will be going up.
Right. So PQW, the W is going to go up because you see that rotation, right? What would be, assuming this is the perigee, that would be
So it's a P, right?
that would be the P axis or the P direction.
Now, how do we distinguish? Like, how do we pick that p-axis? Just pick anywhere coming out of Earth.
How is perigee defined?
The perigee is like the closest point of.
Right.
Okay.
The
So
closest
we
point.
should assume that that's the closest point.
You can assume, that's what I told you. Assume that that's the closest point. When you're talking about one, geostationary orbits are circular orbits, circular equatorial orbits. Thomas, are you doing anything important in your computer? Okay. Pay attention here. So now, what you're trying to do here is, so now think about, you're trying to define the orientation of each PQW frame with respect to the ECI frame. You realize there are 2 PQW frames here. So what is the relative orientation here of the geostationary frame
ECI.
with respect to the ECI frame?
So it's like 90 degrees. So.
Well, no, what if you said
It's 180 or what? What is it? It's actually 90 degrees above z-axis.
about the
Realize why?
So so the inclination is cosine inverse HZ.
Don't worry about the inclination right now. Don't worry about the inclination. Tell me what is the relative orientation of the geostationary PQW frame with respect to the ECI frame?
You said 90 degrees about the Z axis.
90 degrees about the Z axis. You think about this. ECI frame, X axis is coming out, Y axis is in the board, in that where that my cursor is, right?
So
The PQW frame, everything this, it is still, this is W, but the P is in that cursor direction. So if you do a 90-degree rotation, come on, wake up.
Q goes.
About this W axis.
If you do a 90-degree rotation, what happens?
Q goes inside.
Huh?
Q changes.
Where is Q?
Q is going inside.
Q is going inside. So if you rotate ECI frame 90 degrees, you will end up in PQW frame. You don't see that?
Okay.
So, I thought
Q
the
and
momentum direction was in the Y direction.
It's Z direction.
It's in the Z direction. So, why
W.
did you write that? Is that what?
because that's what the polar orbit.
Oh, that's what the
Polar orbit is, it so happens that we'll talk about the polar orbit.
Okay.
Okay?
so, but you mentioned that
Rotate ECI frame by 90 degrees in the positive sense.
so,
What will happen? Rotate ECI frame 90 degrees. Try to do it
in our heads.
in your right-handed sense. Rotate it 90 degrees.
Then it becomes a dividend.
Huh?
It's all
Huh?
PQW.
The Y axis changes 90
Do
degrees.
the line with
So
the
the-
PQW?
It will align with PQW.
So
Look,
why
look
would we
there.
come out
Forget
at-
about this. Look there.
Why would we
The
come
L
out
turns
and Z?
to 90.
Why would we come straight out at you and X would be going out to the side?
Your X, which is coming out,
Yeah.
will go to the cursor. Right?
Yeah, yeah, X would be going to the side now.
And the Y, which is going to the cursor, will go at the back.
Yeah, that. So-
That is the PQW.
Okay.
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 Can you draw that?
See, now I thought that the vernal equinox doesn't move, but it rotates.
I'm not understanding.
We're-
Because
That, I'm trying to define the orientation of PQW
Yes.
with respect to ECI. So the ECI is not moving. If I'm saying if you align, let's say you align PQW and ECI first, and you rotate PQW
Then,
by 90 degrees,
then you'll have it.
you have the PQW.
Okay.
This is ECI, okay? You see this ECI? You see this ECI? Right? On that, this is x-axis, y-axis, z-axis.
Yes.
Where is PQW?
PQW is the 90 degrees rotating.
X-axis, y-axis, z-axis. So if I do a 90-degree rotation of the ECI, I'll end up in PQW. You see it?
Yes.
So you see the orientation, how we are expressing PQW. 90-degree rotation about z-axis is PQW. Got it? Now do the same thing for how do you define the PQW frame for the polar orbit?
Z-axis is where the cursor is.
Huh?
The Z-axis would be where the cursor
Z-axis is where the cursor is. Why? Somebody else answer?
Rotates about the x-axis.
About the Y.
Because it's rotating in this direction, you're
The not the z-axis. He is talking about the w-axis. Okay. Why is the w-axis going to the cursor for the geostationary orbit?
because according to the right-hand rule, you have to put your thumb out this way for it to rotate, orbit around the Earth. So that's the reason.
Do it, everybody try to do it. Why is W axis going to the cursor for the polar orbit? You understand what the polar orbit there is?
Because the polar orbit is rotating about that, the angular momentum is going about that, the pole axis.
So you see this
Right.
polar orbit is like this, right? So it's like this, correct? It's like this. So my Z has to be this. You see this? My hand, this Z, your axis of rotation is like this. Why was W axis, the angular momentum for geostationary orbit, same as Z axis? W and Z were the same for the first geostationary orbit. Why?
Because it was rotating.
Earth is also rotating like this. The satellite is also orbiting like this. You see it?
Yes.
For the polar orbit, how is it doing?
90 degrees.
It's 90 degrees. Earth is rotating like this, but the
With the
orbiting body is like this. This is the equatorial plane. This is the orbit plane. So orbit, it's doing like this. If this is the equatorial plane, if this is my equatorial plane, okay. So equatorial plane means Earth is rotating like this. So this becomes my axis of rotation or Z axis. Now where is the this is my orbit, okay? So you see the orbital plane. Now where is the, if the axis of rotation is this, not axis of rotation, the motion, orbital motion is this. So it has to be, you see this, my hand direction? That is my W axis.
And your X is going up. Yeah, your X is going up and your Y is coming out this way.
X and Y you should define using, now when you say X and Y you should say P and Q.
G and Q, so your P is going up.
If P is just the direction of perigee. Wherever your perigee is, so if you assume the perigee is this, if this is the perigee, then yes, P would be there. And Q would be coming up.
And if you rotate 90 degrees, you should be going down.
Right.
P would be right there.
Right. So you see, what we are trying to do is, we are trying to define the relative orientation of this frame. The relative orientation of this frame defines the relative orientation of the orbit. If I don't show you this, figure, if I just give you the matrix, this figure will pop up in your mind.
Okay, that's what I want to see.
Okay? Now tell me what is the relative orientation of the polar orbit?
Excuse me?
What is the relative orientation of polar orbit? It is 90 degrees above some axis. What is that axis?
Oh, it's 90 degrees about the X axis or the Y axis. I'm gonna say.
The relative orientation. So this is my
XY.
equatorial plane. Okay. This is my x-axis. Okay. Now I can either do, this is not the orbit. This is about y-axis, right? This rotation would be about y-axis. This is not my frame. If I do this about x-axis, you see my x-axis is here. So this is, now let's say this is x-axis for you guys. According to that, this is z-axis, this is y-axis, right? Now see what I am doing. This is my x-axis. I am rotating this way. This is what frame is this? This is the orbit, the PQW frame. So it is 90 degrees above x-axis. Okay. The polar orbit is 90 degrees about x-axis. The Geostationary orbit is 90 degrees about z-axis. So in reality, what happens is orbits can be somewhere between, they can be anywhere between an equatorial orbit to a polar orbit. They can be somewhere like this. Okay, they can be somewhere like this. They will not always be perpendicular about one of the axes. So that is when we use this orientation. Okay. I guess you'll have to do this homework on your own.
So